Okay, managing interference, types of interference, incidental, propagation changes can cause it. Not maintaining proper frequency separation can cause it. Harmful interference is prohibited by FCC rules and regulations. We've covered that before. Malicious or intentional interference, that's the one that's going to put you in the poorhouse, literally. Prohibited by FCC rules and regulations. When propagation changes during the contact create interference from other stations, attempt to resolve the issue with the other stations in a mutually acceptable manner.
Courtesy.
Almost every time, one of you say, hey, no problem, I'll move, or we'll move, almost always. And if it's easy for you and whoever you're talking to move, offer it. To avoid harmful interference on an apparently clear frequency before calling CQ on CW or phone, what do? Listen. Oh, and send QRL on CW, followed by your call sign. Or if using phone, ask for the frequencies in use, followed by a call sign. So they're saying apparently clear, you've listened already. So then you say, hey, are you guys out? Is anybody using it? QRL is just the frequency in use. Symptoms of RF transceiver feedback. Voice transmissions may be garbled. Okay, feedback, garbled, distorted, unintelligible. You got a list. What's the answer going to be? Most likely. Pretty sure when we get to the questions you'll see that. Avoiding interference. Be smart. Know the band conditions, propagation, busy times. Use directional antennas because the directional antenna sends most of my power that way. Doesn't send as much out there and a lot less to the rear. Reacting to interference, change frequency or the antenna. So if you have multiple antennas, point different directions, you can change the antenna or you can turn the direction of the antenna. Have a backup plan. Keep cool. Yeah, don't get mad. Don't get upset. It's a hobby. CW modes. Continuous wave or Morse code. Best mode for weak signal conditions. You can get a CW signal through with a key and ears through all kinds of noise, where you will never get a voice comm through.
Correct.
All you got to do is hear that difference in the noise, and you can pull the CW out. Computers with digital modes can do the same. You can send a tiny little signal out and be heard all around the world, if the propagation is there. Okay, permitted on any amateur frequency, CW. Courteous operators stay in segments that are specified for CW because if you're going beep, 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 we can't talk. Unless we can just drown you out. It makes it real hard to listen and you don't want to do that.
It's very hard to drown out a CW signal.
It is very difficult. So, and you should never try to. But what happens is on a busy net, they'll call for check-ins and there'll be a guy on voice and a guy on CW at the same time and you will not hear that dude on voice. AM and SSB phones. Single sideband is the most common mode on HF. Single sideband is narrower bandwidth than AM. It's got more punch, that's why we use it. It's not because of the bandwidth. Single sideband is more power efficient. Single sideband is permitted in at least some portion of all the amateur bands above 50 megahertz. Single sideband, know which sideband to use. 60 meters is upper only by regulation. On all other bands, sideband is dictated by convention, not by regulation. So when and where you use upper sideband, lower sideband, even though conventionally we use it at 14 megahertz, we just change. It's not regulated. You can use whichever sideband you want. But you're not going to talk to anybody calling CQ if you're on the opposite sideband of everybody else is using. Okay, refer to your band plan. Okay, which of the following indicates that you are looking for an HF contact with any station? Somebody had the answer already? Okay, I heard it, Charlie. Charlie's correct. All right, here we go. Which mode is most commonly used for voice communications on frequencies of 14 megahertz or higher?
Alpha.
14 or higher is alpha, upper sideband. Which mode is most commonly used for voice comms in the 17 and 12 meter bands? Bravo. No. 17 and 12 is upper. How close to the upper edge of a band's phone segment should your displayed carrier frequency be when using 3 kilohertz wide upper sideband? How close to the upper edge if you're using upper sideband? How close could you be?
Probably.
At least 3 below the edge of the band. I'd go 3.5, just be sure. How close to the lower edge of a band's phone segment should your displayed carrier frequency be when using 3 kilohertz wide lower sideband? Alpha. What if you're using upper sideband and you're at the lower end? What? If you're using at your lower end of the band, using upper sideband, where can your carrier be? 3 kilohertz above the upper sideband's lowest limit, right? No,
Right on the band edge.
right on the edge, because you're on the lower end and you're using upper sideband, so you can go right on the edge of the
All your
band.
signal will
And
be
your
in
signal
band.
will all be in band, okay? That's one of the things that people get confused about. That's why they have these 2 questions in here. But why should you not set your transmit frequency to exactly at the edge of an amateur band or subband?
Delta.
It is delta, all of the above. Which sideband is normally used for 10 meter HF, VHF, and UHF? All the higher stuff is upper. Which mode of voice communication is most commonly used on the HF amateur bands? What's the most common voice? Charlie, single sideband. Which of the following is an advantage when using single sideband as compared to other analog voice modes on amateur bands? Less bandwidth and greater power efficiency. Which of the following statements is true of single sideband? SSB. Agree? Disagree?
I agree.
Bravo is correct. One sideband only. The other sideband and the carrier is suppressed. The receiving station inserts a mirror of the sideband and a carrier. What is the recommended way to break into a phone contact?
Bravo.
It is Bravo. Say your call sign once. You're breaking into an existing contact. You just throw your call out. Why do most amateur stations use lower sideband in the 160, 75, and 40 meter bands?
Delta. Yep, Delta.
Commonly accepted practice. It's not more efficient. It's not the law.
Nope.
And it's not fully compatible with an AM detector. Okay. Which mode is most commonly used for voice comms on the 160, 75, and 40 meter bands?
Bravo.
Lower. Generally, who should respond to a station in this contiguous 48 states calling CQDX? Charlie. Outside the lower 48. So Alaska and Hawaii might respond. When selecting a CW transmitting frequency, what minimum separation from other stations should be used to minimize interference to stations on adjacent frequencies? CW. Bravo. Would that do it? 3 to 6 kilohertz? That definitely makes it, right? But that's huge.
That's an awful lot of room.
It's Bravo. It's a little tiny one. 5 to 50 won't do it. But 150 to 500 will. What is good amateur practice if propagation changes during a contact, creating interference from other stations using the frequency? Okay, what's the answer? Charlie, attempt to resolve the interference problem with the other stations in a mutually agreeable manner. Which of the following is true concerning access to frequencies in non-emergency situations? Charlie. Nets do not have priority. When selecting an SSB, single sideband, transmitting frequency, what minimum separation should be used to minimize interference to stations on adjacent frequencies? Now we're talking about single sideband. Well, we know it's not B because we answered that for CW. 3 kilohertz is correct. Okay, how can you avoid harmful interference on an apparently clear frequency before calling CQ on CW or phone? Before you call CQ, what do? Alpha? Send QRL before calling. You listen for 2 minutes, then you send QRL, then you send CQ. Okay, which of the following complies with commonly accepted amateur practice when choosing a frequency on which to initiate a call?
Alpha? When choosing.
When choosing a frequency.
Yeah, right.
Follow what? See, they're tricky.
Yeah.
Follow the voluntary band plan. Okay, why do many amateurs keep a station log? Delta. Okay, which of the following is required when participating in a contest on HF frequencies? Required? Charlie? That's normal. That's just everyday operation, right?
Yep.
That's the only thing there is. Why are signal reports typically exchanged at the beginning of an HF contact?
Delta.
Not Delta. To allow each station to operate according to conditions. Receiving. FM receivers normally only have volume, squelch, and frequency controls. FM receivers. Single sideband and CW receivers have many more controls. Okay, do not be intimidated by a radio that has lots of knobs and buttons. You want those.
They're there for a reason.
They're there to make your life easier because you don't have to search through a menu on a little box like this. It's got everything in it, and everything's in a menu, and you have to go, what menu number was that? Selectivity. Ability to reject strong signals close to the desired frequency. So this is where the Baofeng sucks. It is not selective. So if there's a strong signal near the frequency you're on,
It's going to invade you.
it can. In practice, it's not usually a problem. But if there's a problem, and you got a Yaesu and a Baofeng, and there's a problem on the Baofeng, the Yaesu is highly likely to not have that problem. Or any other than the name brands. Okay, more important than sensitivity. Primary noise source is atmosphere rather than receiver circuitry. Phone, HF. Vox, voice operated transmit. We talked about that. Do not use Vox unless you really know what you're doing and you're really confident. But there are circumstances to use it. Okay, allows hands-free operation. We covered that earlier. So, 3 controls: Vox gain, Vox delay, and anti-Vox. The Vox is a voice operated transmit and allows hands-free operation is the test. Digital communicating by encoding characters is a combination of bits, consists of a protocol and a method of modulation. What is the requirement for the digital protocol? It has to be published. It has to be open to the public. Protocol, rules for encoding the data. Where to find activity? Restricted to CW data segments of each band. Usually close to the top end of the CW segment. So the CW segment is at the bottom end, and close to the top end of that little piece is where you'll find the digital stuff. Exception is 160 meters. So the yellow ones are the numbers on the test. So 80 is 3.57 to 3.6. 20 meters is 14,070 and 14,112.
And please note, this is digital mode frequency.
Yes, digital. So they're going to ask you a question, probably one of these two. Okay, 80 meters is 3.57 to 3.6, and 20 meters is 070 to 112. And those are, you have to memorize those. That's Morse code. It's transmit and receive switching. MOX is manually operated switching. Semi-break-in or semi-QSK. I've never understood that. Somehow break-in, you can send in between the dots and dashes. Full break-in, full QSK, the operator can hear incoming signals between all transmitted code characters and elements. Doesn't that just make it go beep? I don't know, but that's a test question. Full break-in, full QSK, the operator can hear incoming signals between all transmitted code characters and elements. Now, if the operator can pull out 2 signals and write them down at the same time, that boy needs a pay raise. 0 beat operation is on the test. Matching your transmit frequency to the frequency of a received signal. So Dave's sending it out, and one of our radios is off a little bit. 0 beat to frequency, or 0 beat operation is me dialing him in. Now, I don't want to chase him, so if I dial him in and I'm now off from him, he'll dial me in, and I dial him in, and
Then you're walking up the band.
so we have another thing to do, and I don't know if that's coming up next or not.
RIT it better be, yeah.
0 beat is matching your transmit frequency to the frequency of a received signal. By using the opposite or reverse sideband when receiving CW, it may be possible to reduce or eliminate interference from other signals. Okay, that's a straight key. It's on or off. That's what they started life with, up and down. That is a single paddle key, so it's got 1 bar. It's got 2 little things on it, a fat one on one side and a narrow one on the other side. But it's just 1 bar, and you go left and right. The length of contact is controlled by the operator, so you're manually making the da and the di by how long you hold it to the side. You got to train yourself to make them consistent. Press this side for a dit, press this side for a da. Semi-automatic, looks the same, doesn't it? But it's got some stuff in it. It's called a bug. Press to the left, it makes a continuous contact suitable for sending DAWs. Press to the right, a horizontal pendulum is set into motion which rocks against the contact points, sending a series of short pulses or dits at a speed which is controlled by the position of the pendulum weight. Okay, it's not on a test. Basically all it's saying is if you push it one way, it gives you 1 dit. Dit or daw? No, daw. 1 daw. So you got to manually do the daws. If you push it the other way, it will automatically give you the dits over and over and over until you turn loose. This one is a dual paddle key or iambic. Responds to a closure of both levers at the same time by sending a series of alternating dots and dashes. So some of
Which means they
the
have added a real high level of confusion.
the yellow around this does not mean it's on the test. That's just highlighting it. There are points in CW where pulling them together and getting a dit dot, dit dot, dit dot makes it easier because you're going to send some dit dots for a while. Okay. CW electronic keyer, here's how you do it. This is an electronic keyer that assists in manual sending of Morse code. My understanding is I'm sending it into it and it's got a buffer, and however slow or fast I got it going in there, it makes it uniform when it comes out. It assists in manual sending of Morse code, an electronic keyer. Automatically generates strings of dots and dashes. So, I don't know, but that's the test question. It's built into most modern transceivers. This is the way to make CW. It's a keyboard. Type the message in on the keys, goes into a box, and the box spits it out as CW. And then when the signal comes back, your computer can actually decode it for you too. I don't know.
Does it still give a gap between the words?
Yes, that's what the pause is for. Or
It
the,
does everything. You type it, if you put well, there's no space bar, is there?
no, but if you look at the lower left-hand corner, there's a BT.
Ah.
That's the break transmit.
So you have to hit that between every
Well,
word?
with this board. But I'll guarantee you, there's software out there that will take your computer standard keyboard and allow you to send Morse code. But that's cheating. If you talk to an old timer, that's cheating. And they can tell if it's hand sent or
Sure,
machine
yeah.
sent. Because in World War II, they actually could tell the difference between that operator and that operator by their fist, by their hand.
Yep.
That's right.
And they would go, that's not the same guy sending them. We got a new guy here. Hey, let's listen close. He might make a mistake and give us the key to break in the code. Abbreviations are used to shorten
Yeah.
common phrases.
Yeah.
RX is receive. Why send out RECEIVE when you just go RX? XMT, transmit. WX is weather. TX is telephone. DE, this is. That is, I'm sure, from French. ES is and. S is 3 dots or dis, and E is 1 dit. So that's making it shorter than A and D. That's why just cutting one letter out, it's a much quicker. At the worst, it's dit da da da, and you're done. Whereas I don't know what A and D takes, but it's more than that. Okay, FB, fine business or okay. FER, for. Why would you do FER instead of FOR? Because E is 1 dit.
Oh, it's 3 dashes.
O is 3. Shortens it. That's how important it was to make them things easier. CUL. Oh my God. So the guys on their cell phones think that they started the LOLs and the emojis and see you later. CUL. AGN again. Okay. Throw signs are used to organize, control communication. These two that are yellow are on our possible test questions. AR, end of message. KN, go ahead only. Listing only for a specific station. Q signals, replace an entire sentence or phrase with a group of 3 letters. Originally developed for the commercial radio telegraph service in 1909 to shorten up how much time they were on the air so they could get more messages out because they charged by the message.
Actually, originally it wasn't even air-based. This is telegraph stuff.
Oh yeah, that's true. It was telegraph. Add a question mark to change a statement to a question. I'm fine. Are you fine? Okay, here's the ones that are on the test. QRL, I am busy. Are you busy? This frequency is in use. Is this frequency in use? Either one of those, depending on the context. QRM is I have interference. Do you have interference? QRM is man-made. QRN, I am troubled by static. Are you troubled by static? QRS, send more slowly. You'll hear that a lot with a new guy, I'm sure. QRS as a question is, shall I send more slowly? QRT, or QRT with a question mark. Oh, that's not on the test. QRV, I am ready, or are you ready? QSL, I am acknowledging receipt. So he's sending me his exchange, okay? KJ, I've already got his call sign. He gives me a 59 Oregon Jackson. I'll go, QSL, we are 59 Oregon Jackson. And he'll go, QSL, he should give his call sign. I give my call sign. That generally goes away on the contest. And we're done and off to the next one. QSL, I acknowledged receipt. Or he'll say, we are 59 Oregon Jackson. QSL? He's asking, did I get that? I go, QSL, I got it. QSY, change frequency. Shall I change frequency? and you can throw in the frequency. So, hey, you want a QSY to the other one? Well, some of us, I used to talk to Nat all the time, and we use 14652, and we're going to be on a while, we can use 14655. I say, hey, you want to go to the other one? Yeah, QSY, and we're out of there. Draw our call sign, because we're ending our communications on that frequency. So QSY is change frequency, or shall we? Signal reports. Okay, readability, strength, and tone. Readability and strength, tone is only for CW. So if you're on voice and someone says 599, laugh. Just don't key up when you're laughing. Okay, used to exchange information about the strength and quality of radio transmissions. There's the readability scale, 1 to 5. So 5 is perfectly readable. If you're unreadable, I don't know why you'd ever get a 1, because I can't hear you. Barely readable, so if you get a 2-9, you're barely readable, but you're really kicking in. You got tons of power, but you're barely readable. There's something wrong. Strength, 1 through 9, very strong signals. So you might be 60 over, but I can't understand the word you're saying because something's wrong. You could be a 2, 9. That tells the guy sending, I might have some problems with my system because I got power going out, but I don't have the information going out. Okay, the S meter on the radio is an attempt to quantify signal strength readings. S9 is defined as 50 microvolt signal at the antenna terminals. 50 microvolts. Okay, signal reports for tone, 1 through 9. There's nothing on the test about that. Tone is emitted when you're on the phone. When using CW, C at the end indicates unstable tone or chirp. So you go 599 Charlie. K at the end indicates key clicks. Key clicks, I think we talked about earlier, is how sharply it initiates. If there's a bit of an angle to it, there's no key clicks. If it's just sharply on and off, there's key clicks. X at the end indicates exceptionally stable tone, not used often. Charlie's the only one you got to know. C at the end indicates unstable tone or chirp. Zero beat, we talked about that. Adjusting your transmitting frequency so that your signal and the other signal are on the same frequency. Two signals will then produce the same audio tone in a receiver. Okay, which of the following statements is true? Vox operation versus PTT. Bravo. Hands-free operation. Which of the following describes full break-in CW operation? QSK. It is Delta. Full break-in or QSK is you can receive between the characters. What should you do if a CW station sends QRS? Send slower. So one of the things about CW is if I'm listening and somebody sends out a CQ on CW, when I respond, I should only send it at the speed that he sent it.
That's just good courtesy.
That's good courtesy, because if he's new and he's trying to make some contacts and he's doing 5 words a minute, and I don't want to blast him, he's going to go like, oh, I heard somebody, but I have no clue what you said. Okay, what does it mean when a CW operator sends KN at the end of a transmission? Charlie, listening for a specific station or stations. What does the Q signal QRL mean? Delta. First step is listen for 2 minutes, then send QRL. What is the best speed to use when answering a CQ? I gave this one away, didn't I?
Yeah.
No.
You're on the wrong end of the question.
No faster than the CQ. If you're answering a CQ.
These two right here, this versus this.
Okay, you're answering a CQ and he's sending it 5 words a minute and you spit out 20. No faster than the CQ was sent out because he's initiating it. That might be his maximum speed. He might be sending slower just to get less knowledgeable operators, but you respond with that and go, are you at max speed if you want, if you're in a hurry. What does the term zero beat mean in CW operation? Delta. Everybody agree or disagree? Delta, matching transmit frequency. When sending CW, what does AC mean when added? What does a C mean when added to the RST report?
Alpha.
Chirpy. What is RST? What's R?
C's strength.
Readability, strength, and tone. And there's no tone when you're on phone. What pro sign is sent to indicate the end of a formal message when using CW? End of a formal message is AR. Okay, back to a formal one there. If you are on a repeater, you do not give a 5.9 because the strength is coming out of the repeater, not his radio. So he could be 60 over and horrible. 60 over S9. So you never do a 5.9. The best you can do if you're on a repeater is say your audio sounds good or bad or whatever. Describe the audio. And you should,
Loud and clear.
yeah, and you should do
staticky and mushy. Give an audio report.
Sounds like you've got a 60 hertz tone on there. You might have a ballast or some appliance in your house that's interfering. Whatever it is, give them a report of how the quality of his audio. Not 5.9. Guarantee you there would be people that haven't pushed the button, but they're laughing. What does a Q signal QSL mean?
Charlie.
I have received and understood. Right. What does Q signal QRN mean?
Delta.
I'm troubled by static. What does Q signal QRV mean? QRV, that's the last one we did.
Delta.
Ready to receive. What is the function of an electronic keyer?
Bravo.
Automatic generating caution dashes for the CW operation. Now, it doesn't automatically, you can't just talk into it and have it spit it out. I'm sure that's coming. Somebody's going to go like, you know what, let's do some chat GPT stuff. What is the benefit of using the opposite or reverse sideband when receiving CW?
Charlie.
Maybe possible to reduce or eliminate interference. Yes. Which Q signal indicates that you are receiving interference from other stations?
Alpha. Good.
And what's your key? Interference from other stations would be man-made, right? And that's M, QRM. Which Q signal indicates that you're changing frequency?
Bravo.
Bravo, QSY. What's QRT? You'll hear that one. I'm done. I'm out of here. QRT. What is a symptom of RF feedback in a transmitter or transceiver? RF feedback, what's the symptom? Garbled, distorted, or unintelligible voice transmissions. So it wasn't all of the above, it's its own answer. What is an electronic keyer?
Charlie.
Manual sending assistance. Which is following is good practice when choosing a transmitting frequency to answer a station calling CQ using FT8.
Charlie.
Yeah.
Charlie.
Try again, Charlie's.
Delta.
Delta.
Yeah.
And if you use during the same time slot as the calling station,
It's not clear.
yeah. So FT8 is 15-second time slots. He sends, you respond, he sends, you respond. In a minute and a half, you've got a contact and you're done. And your clock has to be really, really close because if you're off by 2 seconds, those time slots aren't going to line up and it won't work. So the website you want to use is Time Is. And that will tell you the exact time and tell you how far off your computer is.